Thank you for coming. My name is Karan. This is my 5th year presenting at AppSec. I just realized that. So in this talk, I'm going to talk about how to build your first DevSecOps pipeline. We all know DevSecOps is a very hot area, very hot topic in information security landscape, and there's lots happening. So from last few years, I've been focusing on DevSecOps. I've been helping a number of businesses with their DevSecOps journey. When I was thinking about the topic for my talk this year, I thought, okay, why not DevSecOps? A little bit about myself. I'm the founder of OWASP Security, a company that offers services in DevSecOps space and offensive security services. Done some customary certifications. I'm passionate about DevSecOps, as you can see. I'd love to do mobile and web application pen testing and also code auditing. You can see my Twitter handle, and I also have a YouTube channel which you can follow or subscribe to, and I do post content very often. And this goes without saying, this conference probably wouldn't have been possible without our great sponsors. Thank you very much for again, helping and supporting us. So this is this talk's agenda. This is what I would like to cover. As you can see, I just want to build this talk based on what DevSecOps is, why DevSecOps is important in today's information security landscape. We will uncover some of the DevSecOps buzzwords that people talk about, and if you haven't heard about those buzzwords, probably I will try to explain those to you. We will look at a functioning CI/CD pipeline that I've built in my own lab, where I've integrated security tooling to identify security issues as early as possible. We will look at the traditional security approach versus what the shift left approach is. And then we will look at the practical walkthrough of the lab and how we've built that whole DevSecOps pipeline. And hopefully you can take away things or two from that pipeline and implement in your own CI/CD pipeline. So just to sort of, to get things started, what is DevSecOps? Why do we need to do this and what this is in the first place? Well, it's short for development, security, and operations. It started with DevOps, and we realized as security professionals that we can't keep up with the number of releases or the speed of the whole agile development and operations delivery. So this name has gone through so many evolutions, like people call it Sec DevOps, DevSecOps, rugged DevOps, and whatnot. But I sort of stick to DevSecOps. So this is what it's short for. So the whole idea behind DevSecOps is to integrate security into your DevOps pipelines so we can catch security issues as early as possible. So we are not relying on a single pen test that happens every year, probably after 30 or 40 releases in that whole 365 days. The idea is to integrate security from your build to deploy and when you're maintaining that whole product. So you can see there are a number of phases when you're building your pipelines. We want to embed security at every step. And this is your usual diagram that you see what DevSecOps is. And this is a loop, as you can see, because what it's trying to do is it's trying to provide you feedback as early as possible. Again, you're not waiting for one pen test after 1 year to get your feedback or get your assurance on your product. This provides you in real time. Again, why DevSecOps? Well, I talked about it. We want to catch security issues as early as possible. We want to get visibility into other areas of the business or into in your DevOps practices to catch security threats as early as possible, because without visibility, we are not going to know what is actually happening across your organization. It also helps shorten your development life cycles, and you would wonder how, and I'll explain you in the upcoming slides where it really shines if you have your security automated. And when you have DevSecOps program implemented in an organization, you're working really, really closely with the developers. So the developers don't see you as a blocker. Security is not a department that's always going to say no. We're actually helping the DevOps team enable things and move things faster. From the agenda, as I talked about, we're going to now look at some of the buzzwords that we see. You may be familiar with these or may not be, but we will go through those buzzwords one by one. The first one you see or hear very often is called SAST. So what SAST is? So SAST stands for Static Application Security Testing. At a high level, it's just reviewing your application security code, or it's also known as white box pen testing, right? But it's short for SAST. So there are a number of vendors. I'm not affiliated to any of the vendors, so the tools that I'm going to talk about, I'm not encouraging or not sponsoring any of those. I'm just going to talk about the tools that I've used in my day-to-day, and probably you may have also used these tools in your production environments. So SAST, Static Application Security Testing, your application is not running. You're just running a tool, and that tool's going to identify vulnerabilities in your source code. It's going to look at sources and sinks, and based on the tool that you've implemented, it's going to start highlighting those vulnerabilities for you. So typical vulnerabilities you would see, probably cross-site scripting, SQL injection, SSRFs, open redirects, and whatnot. So you're going to see those sort of vulnerabilities if you're running a SAST tool. Example of some basic SAST tools you can see, there is a Sonar Cube, they have a community edition, they have an enterprise edition, and they have a developer editions. Then you have Sneak. Yes, they have community edition, which is free, and then they also have enterprise versions and Veracode. Another buzzwords that we hear a lot is dynamic application security testing, or DAST for short. So in dynamic application security testing, you're actually running the application and you're scanning the application with some sort of tooling. There are a number of players in the market that offer this particular tools as well. Some examples, AppScan and Checkmarks. So the difference between SAST and DAST is, in DAST, you're actually running the application, and in SAST, you're not. You're just simply looking at the source code and you're finding the vulnerabilities. So the type of vulnerabilities would vary, right? So people who are pen testers here or bug bounty hunters, they know what the difference is. Another buzzword that's probably making more and more noise in the last couple of years, it's probably not a testing tool, but more of a protection within your web applications, is called runtime application security protections. So what this allows you to do is embed security controls in your applications in a way that your applications start defending itself against application attacks. So there are very few vendors, as far as I've studied, who actually offer this particular technology. So very, very interesting technology. Don't confuse this with web application firewall, because there's been a bit of a debate about it. So as you can see, some of the vendors who offer runtime application security protection. And also the next one, which is called the interactive application security testing. So what interactive application security does, it takes all the goods from SAST and DAST and tries to merge those pros of those two technologies together. But it also has its own agent that you need to deploy on your web application server. And what it does is it provides you enough and very, very good coverage of your source code, which you may miss if you just simply run a SAST or a DAST tool. So that's where your interactive application security testing shines. And some of the vendors you can see there. Another one that we hear is SCA, or software composition analysis. In short, software composition analysis allows you to identify vulnerabilities in your third-party dependencies that you have in your projects. So those could be JavaScript dependencies. We all know how much we love the Node packages, or a language specific that are your Python, Go, and whatnot. And some open source tooling, and again, some commercial tooling is available to detect those dependencies as well. Last but not least, ISC, or infrastructure as code. Those who haven't heard about infrastructure as code, it just takes away your manual process of creating and deploying infrastructure. This is about writing configuration files and deploying infrastructure. As a developer, you just tell what you need, and you specify in the configuration file, and your infrastructure will be spun up. Your typical ISC providers, AWS CloudFormation, the one that I probably like is the Terraform. I use day-to-day basis, but there are other vendors as well. So these are your typical buzzwords that you hear when you are in the DevSecOps space. There may be more, but that's all I could cover. Right, so let's talk about how so far we've been dealing with, with the security or security assurance work and all of that, and how our security really fits or fit into our traditional process. So various stages, right? From development, we're building stuff, we are doing the QA, quality assurance, we are then deploying that to production, we've done our unit testing, we've done our functional testing, we are all happy, and then we bring a third party in to do a pen test, and done. Now, when will the next pen test happen? That may be a year from now, 6 months from now, but as a company, you're still releasing software. You still have new releases every week or every 2 weeks. Who is providing you assurance for those releases? Probably no one if you don't have any security tooling automated in your pipelines, right? So this is the traditional process, right? Now see, from that pen test, the pen testers found, we found a SQL injection, right? There's a SQL injection vulnerability that came up from that pen test. Now, we will go back to our development to fix that vulnerability. And as you can see, we waited so long to get that feedback, right? Because that vulnerability may have existed in your platform when you probably developed that product. But you didn't get that feedback, you didn't know that vulnerability existed until you got a pen test done. So this is your typical traditional security assurance that we get from a typical deployment pipelines. Let's look at the shift left approach. Yep, cool, we've got this pipeline, but say we've got some tooling embedded into our one of these stages. Say we've implemented source code review tooling. If there was a SQL injection, that stage would have picked it up every time you would release code to production. And then the feedback will be sent back. Or someone will be notified that the tool has identified these many vulnerabilities. Unless you sign it off, the build or the pipeline will not progress, depending on how mature your DevSecOps maturity is. So as you can see, the feedback is quite rapid there. But to take it up a notch, we can start implementing these tools every step on the way. So as developers, you may be using those IDEs. You can have IDE plugins. There are commercial offerings. There are free offerings. You can have plugins for your IDE environments. And those IDE plugins will provide you feedback in real time while you're typing your code. And that feedback could be related to, if you are using any insecure practices in your code, that IDE plugin will highlight that. And then if you have a secret detection tooling enabled in your pipeline or your source code repository, it's going to pick up on any hard-coded credentials that you're leaving behind. And similarly, we can implement SAST, SCA, and whatnot. And you can see where we are getting assurance every step on the way. So every time your build will happen, these tools will trigger, they will produce output, and you will be able to see the issues in real time. You don't have to wait for a pen test that may or may not happen end of the day. And you don't have to spend thousands and thousands of dollars to implement these tooling. You can look at open source alternatives. You can look at, try to perhaps start with an open source tooling to see whether that meets your needs or not before you go for a commercial offering. They have their own place, commercial offerings, because they focus more on less false positive in their output, for example. Yeah, so to see we have these tools now, right? We've embedded these tools every step on the way. I know we are going to look at the demos and stuff, but I just wanted to make sure that we build what I want to show you in the live demo. Lab setup. Well, to show you, I've just created a lab on my computer, as you can see. That's my host machine, and I'm running 2 virtual machines. One is running a GitLab runner. I'll explain to you what that is. And then there's a deployment server. And on the far right, you can see I'm using GitLab. So GitLab, if you're not using it for CI/CD, it's similar to any source code repository or source code management repository system. But in this scenario, I am using GitLab for source code plus for CI/CD. 2 virtual machines that I've created. The GitLab runner runs the job that I create on GitLab. And the GitLab pushes those jobs on my GitLab runner, which I'm hosting on my virtual machine. GitLab allows you to use the shared runners, but I just didn't want to enter my credit card details. So I thought I'd just host my own. And similarly, the deployment server, which you can see at the bottom. So this will host the application that we will deploy through our pipeline. And this will eventually sort of become like your web application server, where your application will be deployed. And then you can reach that application, you can do your scannings, and you can run your tools. And this indication over here is about I'm controlling GitLab from my host machine. Hope that clarifies how the lab is sort of set up. And you can also set up, on your own. It's all free. So the pipeline that I've set up, as you can see, I have 5 different stages: build, test, release, deploy, and integration. And I have given the tools that I've embedded into each stage: SCA, software composition analysis here. We are looking at Bandit. I'll explain to you what that does. Here we have got a TruffleHog, which detects secrets. Then we release. So what happens with the release stage, I'll just explain to you now. So when we hit the release stage, what I'm doing, I'm taking the image, I'm building a Docker image. I'm pushing the Docker image to Docker Hub. And from Docker Hub, rather than running a tool in my pipeline, I'm using Sneak's online community offering to scan that Docker Hub repository to identify issues there, right? And then I'm pulling that Docker image down and deploying that Docker image to that deployment server that I showed to you. And once that container is deployed on my deployment server, it's going to give an IP address that anybody can reach out to, right? And once that IP address is there, once the web application is deployed, I will be running my tools again to make sure that I will be running the DAST scanning again to find vulnerabilities in my applications. So that's how this whole pipeline is set up. Any questions at this point? OK, sweet. Yeah, so that's how the whole pipeline would play out. All righty. As I promised, hope all goes well because I don't have any recordings or anything. So what you're seeing here is I've just logged into GitLab. The very important file of GitLab is gitlab-ci.yaml. So this contains all the necessary steps that you need to take to create your pipeline. I'm going to zoom in a bit so everybody can see it. So this particular file holds everything that you need to build your pipelines. Those who are using GitLab in their day-to-day operations, they know what this file is all about. So what I've done is, for the purpose of this presentation, I am hosting a vulnerable Python application, which is available on GitHub. And then, as I showed you, we've got build, test, release, deploy, and integration stages. And then at each stage, for example, this is just me testing the application, that it's building all right. But while the application is being built, I'm running for example, a software composition analysis here in a container, and then, as you can see, and the output is being produced here. So I'm getting the feedback in real time. If my build has any outdated JavaScript dependencies, it's gonna produce that output, because this is the security tooling that I've integrated. SCA safety, this is specific to Python language. So if your Python has any outdated dependencies, the safety tooling will identify that stuff. And similarly, it's going to produce output that we can look at. One more thing. Now, you guys would be wondering, what happens when the tool identifies issues, right? Because it's going to create errors. It may fail your pipeline. Now, that's entirely dependent on how mature your DevSecOps program is. You don't have to fail the build. You can run it in a transparent mode, like how you would run a web application firewall before you move it into the blocking mode. And what allows you to do that is called allow failure is set to true. Means even if this tool detects issues, rather than failing the build, move on to the next phase. So as a security person, I'm confident that I'm not being a blocker in my DevOps practices or in the pipelines that are being worked on. But at the same time, I can still get feedback from the tools. But once you're fully mature with your DevSecOps journey, you can remove that line, and that's when you start that's when you start really blocking the builds. Because if you don't fix this issue, you're not going to be able to deploy that in production. So that's really, really important, this particular line here. Similarly, we are using static application security testing here, and the tool we are using here is called Bandit. It's Python-specific tool. So if you're running a Python application, you can run Bandit, and Bandit would highlight any vulnerable code, source code that you might have. Similarly, we're running Bandit against our source code, and it's producing a JSON output. And I'll show you when I show you how these jobs are running. TruffleHog, I'm sure some of you may have heard about TruffleHog. TruffleHog helps you detect secrets in your source code. So if you're leaving any API keys, any hard-coded credentials behind your source code, TruffleHog will help you detect that in your source code. Release, as I was showing you in the previous slide, so release, we are logging into Docker Hub. We are building a Docker image. We are pushing that to Docker Hub, and that's it. And I've just used some of the variables that are available within GitLab. So we're pushing our Docker image to Docker Hub there. And this is the chunky one, which is the deploy step. Now, in my scenario, I just have a deployment server that's sitting on my own laptop. In your case, you may have a deployment sitting on a Kubernetes environment. You may be using AWS. You may be using GCP. You may have different deployment environments. It's not much different from what I have here. The concept is the same. So rather than using SSH to log into your deployment server, you may have Google identities that you would be using to deploy this to your Kubernetes and whatnot. The concept is still the same. So this is what's happening here. We are logging into deployment server, we're pulling the Docker image down, we're deploying it on the deployment server, so our application is now running. And the good thing, another important thing to note here is we're mapping port 8000. So you will see when I browse to that, I will have to use port 8000 because I'm specifying it here. And next, ZAP, OWASP ZAP, really, really powerful tool. We are using OWASP ZAP to achieve dynamic application security testing there. So we are running the baseline of ZAP. We're running ZAP in a Docker container, so you don't have to worry about any of the dependencies and you can literally see it's just one line to run ZAP against your application. And you can pretty much copy paste this line and change the destination URL from my production server to whatever application you want to scan, and it'll scan it. And then I'm running another DAST tool called Nikto. Again, similar sort of concept, pulling it down with the container. Don't have to worry about any of the dependencies or installing anything, just running it in one line and producing output. Because automation is the key when you're talking about DevSecOps or DevOps in general. We don't have time to do any input or anything like that. It's all automated. And last but not least, just for the sake of it, I want to scan my deployment server to see what ports are open. And again, similar concept, I'm pulling an image of Nmap, and I'm running Nmap against my deployment server, and that will give me any open ports. So now let's look at, you would be wondering when this pipeline would run. If I change anything in this file, the pipeline will start to run. And I can show you an example. So if I go here, edit something, and say, just add a comment called DevSecOps demo, for example. It's like similar to any push or pull that you would do to your code. I'm just going to commit changes, and nothing's going to happen. Well, it would happen. So this pipeline will start to run. We can see the status by clicking on CI/CD, go to pipelines, and our pipeline will be running. So if I click on that pipeline, I'll show you the one that I've already run. You can see the pipeline is now running. So it will go through each and every stage that we've built. And if you want to see what's actually going on within the job, you can see that here. So that will show you that it's preparing your Docker images. It's going to do its thing, and then we can see more deeply. So I'm going to show you the pipeline that has already been completed, because I don't want to bore you by simply just showing you this. So here's the pipeline that has already been completed, similar pipeline. So build stage, TruffleHog, let's look at the retire.js output, right? Because we want to see whatever outdated JavaScript dependencies are. So you see the job artifact on the right-hand side? So that's going to show you what the outputs are. You can also see it on the console, but this is probably more easier. So I will click on here, show me the output. Cool. I'll just beautify it a bit. And there we go. So in real time, it's highlighted. These are the outdated JavaScript dependencies in our code. I didn't have to wait for a pen test or any other tool to tell me that. I'm not saying the pen tests are not important. I'm just saying we need feedback quicker, as soon as possible. So this is like you're providing this feedback back to developers saying, look, we've got these many outdated dependencies. We have to fix them before we do the next release, right? Similarly, let's look at other jobs that have completed. The one that's been completed, we will look at, let's say, the bandit output, which is a static application security testing. Let's look at what output it has produced, right? Let's beautify it. So this tool produces its output at the bottom, and here you go. It's talking about that it has found a command injection in a Python application, the Python application that we are hosting, and it is vulnerable to command injection. It has highlighted the path to the file, which is here, and it has given it a risk rating as well, and it even highlighted the code that is responsible for it. Similarly, it has found a hard-coded password in the source code, which it has highlighted here. Again, path to the file is here. See how easy it is to identify these issues in your source code. And some of these could be false positive. That's where you have to sort of look at, just need to confirm, yep, whether this is false positive or it's true positive. For example, this last one, those of you who have done code auditing, they may have already realized that this is actually a false positive. Why? Because here, even though the user-controlled input is being entered here, but that $s sign is actually performing parameterized binding. So even when the user-controlled input is ending up here, it will be converted into string. So your SQL injection wouldn't work. So the last one is actually false positive. So as you can see, there would be, and that's where the commercial tooling comes into play, right? Because they say we produce less false positives when it comes to this sort of stuff. So let's look at some cool stuff, which is I like to see is ZAP, for example. So we ran ZAP in our dynamic application security testing. Let's just go back to this job that we have completed. And by the way, here's our application which was deployed. And as you can see, it is reachable on port 8000. And as I said, when we pushed the image to Docker Hub and I ran Sneak, and Sneak has highlighted these many vulnerabilities as well. So you can see you can also start implementing controls for your Docker images and then also for Docker containers. It's just a matter of finding like which tool would fit best for your environment. But it's easier to catch as early as possible. So here I've ran ZAP. So ZAP has found, it said, okay, these many checks have passed, and it has warned me on few, like, for example, HTTP only cookie flag is not set, right? Didn't have to wait for a pen test to tell me that it's not set. We just ran a tool. It's giving me that output. So by running these tools, I'm not saying we're going to catch all the issues, but at least this will help you catch all the low-hanging fruit that you can in your pipelines. But you can tweak these tools in such a way that you will start finding more and more critical issues as well. So this is ZAP's output. As you can see, it has identified heaps of issues. At the bottom, you can see 41 checks were passed, and it's found 13 warnings. And let's see how many ports Nmap found, for example, when we ran the Nmap scan against my deployment server. Part of the same build. And let's look at Nmap. Nmap found port 22 and port 8000 open on my deployment server. Now, you can see why port 22 is open. You can disable that and leave 8000 so people can reach your application. And just one more thing. If I go to CI/CD, for example, under runners, so this is the GitLab runner that I registered, and it's running locally on my computer. I'm not using a shared runner, which you can see on the right-hand side. GitLab allows you to use shared runners, but we are using our specified runners. So if you're building a lab yourself, it's best to use your own runners because it just doesn't take too much space on your virtual machines. Anything else that you would like to know? Because that's pretty much it. Any questions? Was that helpful? I mean, thank you. Thanks. yeah, if you have any questions, please see me outside, and we can definitely have a chat. Thanks a lot for attending.